All right, you guys, here we go. This is the Honors Chapter 3 Geometry Review. And what I'm going to do, I'm just going to tell you straight up before we start this video, what I'm going to do, what I'm not going to do, right? I'm not going to do every single problem on this worksheet, on this packet. I'm going to do three kind of soup to nuts, everything you need to know, kind of three big time problems that involve kind of more advanced skills. But I'm going to talk about just about every problem on here. So you watch this video, wherever you are, this should help you out significantly. So first of all, 1, 2, 3, and 4. The thing I just want you to think about on these is that it's okay to continue the lines, right? Sometimes that really helps students visualize if you just focus on, kind of the parallel lines and the transversal going through it. It can help to make it easier to figure out. And then also don't focus on the things that aren't relevant. So since, for example, here we're talking angle 1 and 2. So this line here with 3 and 4 is just extra information that's kind of put there to confuse you. So following the same strategy for 2, 3, and maybe even 4 can be helpful. Okay, number 5, this is an angle puzzle, right? So you know everything you need to know in order to solve for all 9 of these angles. Right? Things I want you to keep in mind, right? Remember that linear pairs have to add up to 180, right? Remember that vertical angles have to be congruent, right? Remember that corresponding angles have to be congruent if you have parallel lines, which is what you have in this diagram. And that would also hold true for alternate interior angles, alternate exterior angles, and you guys know the rest, right? And finally, keeping in mind that the angles of a triangle have to add up to 180, right? That's kind of the third piece there, right? So if you keep all those rules in mind, you should be able to solve for every single angle in this diagram with no problem. All right. Now, so number 7, actually, 6 is pretty straightforward right there. I mean, of course, there's a couple variables. So remember, obviously, you less variables are better, but keep in mind one thing at a time, right? So solve for one angle, keeping in mind the relationships, right, that you have. When you have, the angles that need to be equal to each other, the angles that have to add up to 180, right? I've kind of already told you enough. You got to kind of figure out the rest on your own. All right. But number 7 and number 8, these are ones where I think a little assistance might help, because I know you could probably look at this all day and get a little cross-eyed. Here's my tip to you. It is okay to draw additional lines if it's going to help you. So what I might do for this one, if I were to kind of extend this line here, right, then all of a sudden I've got a triangle, right? The angles of the triangle have to add up to 180, right? And you also know all your other rules, right, for all those other parallel line angles, vertical angles, linear pairs of angles. And much like that angle puzzle, you now know everything you need to know to find angle X. Okay, number 8, a little, I would say even more confusing, right? Because here, what I would do, if I was solving this, right, I would create additional parallel lines. So do that and see if that will help you on your way to solving for angle X. I think that it will. All right. Now for one of the ones I told you that I was going to do in detail. Now, 10 and 11, they are not identical problems at all, but they follow similar strategies. So I'm only going to do one of them, and then you guys are the ones that signed up for Honors Geometry. You got to figure out how to do the other one yourself. All right. But what I know here, right, I know that these alternate interior angles are going to be congruent, right? So I know that y squared is going to equal 8y minus 15. Okay, now you guys know how to factor a quadratic, and if you don't, well, I'm going to tell you how. All right, so first of all, you can't solve by factoring until you set that equation equal to 0. Yes, this is algebra review. Right, like I told you guys in the last honors packet, there going to continue to be problems where you're going to combine what you know about algebra and what you know about geometry to solve these more advanced problems. All right, so how am I going to factor this? Okay, well, what I want to do is write this in factored form. And so what I need to do is figure out things that will multiply, or I should say numbers that will multiply to 15 and will add to 8. And I always go up the river, down the river. Those of you guys that have been doing math for me for a while. Oh, sorry, that's not 8. That's supposed to be 5. Right? And what combo will get me that minus 8? Well, right there, minus 3 minus 5. All right. Now, if you guys remember how to solve these quadratics from Algebra 1, Algebra 2, wherever you guys are coming from, right, what you realize is the solution is actually not negative 3, negative 5. It's what zeroes this out, right? So 3 minus 3, 3 is the solution, and 5 minus 5 would zero that out. 5 is the solution. These are our two solutions, okay? So I found what y is, but I also need to find what x is. Okay, now, I know, because I got same side interior or consecutive interior, I know that y squared, right, plus x has to equal 180. I guess I also could have said that x plus 8y minus 15 also equals 180. So whichever one works for you, so be it. And what's interesting about this is I've got two solutions here, right? So I'm just going to see what happens. If I make y 3, let's just see what happens, right? So 3 squared plus x equals 180. Which you guys know, 9 plus x equals 180. Subtract that 9 from both sides, and x equals 171. All right. Well, let's see what would happen, right, if I plugged in 5 squared, right? So let's say, so 5 squared plus x equals 180. So now I get 25 plus x equals 180. X equals 155. Now, what's crazy about this problem is actually both of them work, right? So if I were to plug in, because I always got to check my solutions to make sure they work, right? But if I plugged in, let's say 171 here, this is 171, right? This ends up being 8 times 3, or 24 minus 15, which is 9. That works, right? And if you were to plug in 155 here, you would have 155, and then x times 8 times 5 would be 40 minus 50. That'd be 25, I believe. 155 plus 25 also equals 180. So both of these solutions work. All right, and just a little teaser, right? For this one, you may also find two solutions, but keep in mind, they may not necessarily work. So you've got to check that out, making sure that obviously these would both have to be positive numbers because you're not going to have a negative degree angle. Anyway, I've already said too much. You guys got to do problem 11 on your own. All right, number 12. Now, just kind of two key algebraic skills that you're going to need for this assignment. One, we already demonstrated, right? Factoring a quadratic, right? Solving a quadratic by factoring. And now you're going to have to use systems of equations. So that's for number 12, and that is also for number 13. I'm only going to do one of them because, hey, you guys signed up for honors geometry. You got to do something yourself, right? So anyway, I need to find the measure of angle 1 right now. The truth is, I think if I find x and y, I got to find x and y in order to solve for angle 1, right? So a couple of equations here, right? So first of all, I know that, well, I guess I know angle 1 and angle 2, right? These two angles, right, have to add to 180, right? I know that, right? So I could say that x plus 3y plus 2x plus 30 equals 180, right? All right. The other thing I know, right, is that angle 1 and angle 3, because they're corresponding angles, they got to be congruent, right? So those two things are going to be equal. So I could say that x plus 3y is going to equal 5y plus 20. Why do I need to do that? Well, because I have two variables, I need two equations to solve for those two variables. You guys know how we do this. Always simplify before you solve. So I got 3x plus 3y. Okay, I'm just going to subtract the 30 there. That equals 150. Right, over here, again, I'm going to combine like terms. So what I'm going to do is I'm going to say x, and then subtract that 5y from both sides. Ends up being minus 2y equals 20, right? So now I'm in a situation where I could solve by either substitution or addition elimination. totally up to you what you would like to do. I think what I'm going to do here, you know what I think I'm going to do? I'm going to do addition elimination because I'm going to say, all right, so I'm going to make this, so if I get x minus 2y equals 20, right? And I kind of like this because what I want to do, I'm just going to multiply this, keep it as simple, multiply this by negative 3. So negative 3x plus 6y equals negative 60. All right, so remember, if I multiply, because what I really want to do here is I want to multiply this x by negative 3, so they're canceled, right? But remember, if I'm going to do that, I got to multiply every single piece of the equation by negative 3. So just so we don't get confused here, I'm just going to kind of cross this out because these are the two equations that I'm going to add together. Remember, when I multiply the entire equation, I'm actually creating an algebraically equivalent equation. So this equation that I crossed out and the blue equation are actually algebraically equivalent. So here we go. I add these equations together. The x's cancel out. I've got 9y. This ends up getting me 90, I believe, when I add those together, and y equals 10. Oh, that's nice. Nice round number. Okay, but now what I got to do, I know what y is. I've got to figure out what one of these angles is, right? So what's kind of cool here is that we know angle 3 and angle 1 are the same. So if or have the same measure, I should say, if I could solve for angle 3, I've also solved for angle 1, right? So that's great because here I already figured out y was 10. 5 times 10 plus 20 equals 50 plus 20 equals 70, right? And again, I believe, yeah, and I know that if I solve angle 3, I also solve for angle 1. Right, so 70 degrees should be the answer. But hey, if you don't believe me, right, you could solve for x, and then we could always plug it in to see what angle 1 would be. Right, but I'm pretty sure I got the answer right. I'll double check. All right, I will double check, and let's see. Measure of angle 1. Okay, y equals 10. Let's see. So y equals 10. Let's just double check here. So x minus 2 times 10 equals 20. X minus 20 equals 20. X should equal 40. Okay, so why did I do that anyway? Okay, because I'm plugging into angle 1 just to make 100% sure, even though I'm 99% sure. So I get x is 40, right, plus 3 times y, which is 10, equals 70. Yep, so there you go, you guys. I checked the answer 2 ways. All right, the answer is angle 1 is 70 degrees, and that is that. Okay, now 13, very, very similar to number 12, although it got some slight differences. Okay, 14 and 15, all about the slope, right? Remember here, you actually have 2 data points, right? I'll let you figure that out. You guys are the ones that signed up for honors geometry. But that word problem gives you 2 data points, and they are just asking you rate of change. Remember, it's just fancy name for slope. Okay, 16, yeah, you're using the slope formula, right? It's not a traditional problem, but your thing you're solving for is not the slope, but it's one of the coordinates, right? So use the slope formula, you should be able to figure this out, right? 17, right? It looks like you're going to have to draw the diagram, right, and then figure out the slope right there. Okay, and now to fulfill my promise and to do number 18 for you, let's do this. Okay, so find the equation of line 4 if it contains the intersections of line 1 and 3 and the y-intercept of line 2. Okay, and then the information we're given is line 1. They give us line 1. Line 2 is parallel to line 1, has the same x-intercept as line 3, and then, okay. There's a lot going on here. Okay, so line 4 contains the intersection of line 1 and 3. So luckily we got our equations for 1 and 3. That's good. That is good. Line 2, we don't even know what the equation is, right? So we got to figure this out. So let me just figure out line 2. Right, so it is parallel to line 1. Okay, so if it's parallel to line 1, right, we know that the slope is going to be -6, right? Because the slope to line 1 is -6. Okay, the thing is we don't know the y-intercept for line 2, right? So we need to solve for that. right? But we do know that it has the same x-intercept as line 3. So what is the x-intercept of line 3? Well, let's find out. So we got line 3 here, right? We got 6x minus 2y equals 12. And just to be clear, this is line 3, right? Now the x-intercept, remember, is when y equals 0. So you're really going to have a lot of knowledge of algebra to answer these questions, right? The y-intercept is when the x-intercept is when y equals 0, right? So here 6x equals 12, x equals 2, right? And so, just to be clear what we got here, 2, 0, right? This is the x-intercept of line 3. Now line 2 has the same x-intercept, right? So in other words, it contains this point. When y is 0, x is 2. Okay, so here we do a little arithmetic here, a little algebra. B equals 12. So just like that, y equals mx plus b. Right? I know my slope, right? It's -6. I know my y-intercept is 12. Now I've got my equation of line 2. So I have my equation of line 1. I have my equation of line 3. And now I have my equation of line 2. And I can use all that information to figure out my equation of line 4. Now, the intersection of line 1 and 3. Okay, we got to figure that out. So line 1, right? We've got our equation. Right? Line 3, we also have our equation. But I'll tell you what, I don't like the way this looks. All right, make your money on slope y-intercept form. And the reason why I'm going to do that, I'm going to show you this in a second. Again, we got, this is more action with line 3. Right? I'm taking our equation. Right? And I am going to get this in slope y-intercept form. You're going to see why in just a second. Right? So I'm going to divide both sides by -2. Y equals -3x minus 6. Okay, now the reason why that was so good, right? The reason why that was so useful. I'm sorry, that should be -6 because I subtracted 6 from both sides. Sorry, I got a little sloppy there, you guys. This is going to be positive. Let me just rewrite that correctly. Sorry about that. Sloppy mistake, you guys, right? So I'm subtracting 6x, that's why that's -6x, and then I divide by -2, 3x minus 6. Okay, now the reason why that is so good, I got both of these in slope y-intercept form, right? So if we want to know the intersection, right? The intersection also is the solution to the system of equations. If I drew both lines, it was where they would intersect, where they would crash into each other, right? So y equals that, y equals this. So what I can do, right, is that I could set those two things equal to each other, right? So I could say, right, line 1, the intersection, and I'll just write this down, intersection intersection. Sorry about my terrible handwriting of line 1 and 3, right? You know what? Instead of making you guys read my terrible handwriting, I'm just going to circle what I'm doing here. Intersection of line 1 and 3. Right. I set these two equations equal to each other. -6x plus 3 equals 3x minus 6. Okay, I get all my x's on one side. Add that 6x. 9x, so it should be 3 equals 9x minus 6. Okay, add 6. Okay, so that should be add 6 to both sides. X equals 1. Of course, I'm not done, right? The point of intersection, I got to plug that into either of these two equations. Y equals 3 times 1, -6 minus 6. Okay, y equals, I think that's -3. So what that means is that that point of intersection is 1, -3. Okay, so I am almost done. I'm going to move that picture of myself because I don't know why that's important. Move that over here. And now, finally, we are going to find the equation of line 4 over here in red. I say it red. Oh, whatever. There we go. Now it's in red. Line 4. Okay, so remember, make your money. Y equals mx plus b, right? And I'm just going to start trading numbers for letters. Okay, let's see. Do I know it contains this point and has the y-intercept of line 2? Oh, this is a unique problem. So I know it contains this point. So I already have an xy pair that I can plug in. Y is -3. Okay, the slope we actually don't know. X is 1. And then we have the same y-intercept as line 2. Wow, this is really flexing your big league algebra skills. So here we go, m plus 12, right? We're solving for the slope here in case you couldn't tell. So subtract 12 from both sides, and that ends up being negative. What have you ever seen a slope that is -15? Well, hey, you just did. So now we have our slope, we have our y-intercept. All you got to do is just plug it into the equation, y equals mx plus b. Game over, you win. There was a lot there, a ton there. Oh my God, it was like every linear equation algebra concept you've ever seen in one problem. This is an absolute masterpiece of a problem. I credit Miss Kramer and Mr. Can for putting this thing together. Wow. Wow, you guys are definitely earning your honors credits with this one. And the party is not over, because I believe problem 19 is very similar but also kind of different. Right? So you're going to put together some strategies, some skills in order to make that happen. 20, all right, remember, if this is the midpoint, right, these two things are equal to each other. I think I already said too much for number 20. Anyway, this concludes our video. Good luck with the rest of this assignment. Yeah, we'll see you in class.